All right. Solution. And I told you in my class, if I ask you, you have to reply. Don't remain quiet. So all of us, do you know what is solution? Do you know what is solution?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
What is the definition? Tell, don't feel shy. If there is something wrong, I'll help you to correct. What is the solution? So tell, what is the definition of solution?
So when a solid component called solute is dissolved in a liquid called solvent, the solution is formed.
Dear, it's not necessarily that solution should always you have to take solid and you have to take liquid. You can take two solids also. You can take two liquids also. You can take two gases also. Okay. So very simple definition. It is a homogeneous mixture of two or more non-reacting substances. In your book, they may not write non-reacting, but you should be little careful. If I use acid and base and we mix it together, ultimately you will get a separate thing. So mixture is a physical process, not a chemical process. So because of that, we write it is a homogeneous mixture of two or more reacting substances. Okay. All right. The substances which make a solution are known as components. The larger component is called, what do you call it? The larger component? Immediately reply.
Solvent.
Very good boy. What is your name?
Sir, Purohit.
Okay. The larger component is called solvent. And the smaller see, it can be one or more than one. Suppose you have taken sugar solution. Larger component is water. Water is solvent. Smaller component is sugar. Only one. So we call it. Here it will be one. Yes, will not be there. It will be known as solute. Okay. Now suppose you want to make ORS. What do? You take water. To that you add small amount of salt, a little more amount of sugar. So there are two solutes are there. So in that case, it will be S and R. Okay. So now How a solution will look like? If you put sugar in water, how the solution look like? You put sugar in water. That is the first component. When I say sugar in water, means sugar is solute, water is solvent. So if you put sugar in water, how the solution will look like?
It will
Tell
be
them.
Transparent.
translucent.
You don't say like transparent. You say it is liquid, sir. Is it not? If you put
Yes,
sugar in water, the solution will appear liquid. Okay. Now, if you, how many of you know how to make atta at home? Boys to forget. Girls, you know how to
Yes,
make
sir.
atta? What you do?
Atta and water.
Which is solvent and which is solute?
The atta is solvent.
Atta is solvent and
Water is solute.
yes. Then how does it look like?
Sir, it's semi-liquid.
Not semi-liquid. If it's
Semi-
semi-liquid, then you cannot make atta. It will be soup.
Semi-solid, sir.
It is solid only, but only soft. The soft solid. Okay.
Yes, sir.
So what is the meaning of this one? Why did I ask you? See, the appearance of a solution depends upon the appearance of the solvent. If the solvent is liquid, solution will be liquid. If the solvent is solid, solution will be solid. If the solvent is gas, the solution will be gas. See, if you pass carbon dioxide through water, have you seen any solution which contains carbon dioxide?
No, sir.
Nilaya. Any lady, have you seen solution of carbon dioxide in water? Huh? None of you have seen solution of carbon dioxide in water.
So Coke.
Yes. So we call them as carbonated water. It may be Coke, Cola, Coca-Cola, Sprite, all these things. So in that bottle, can you see the carbon dioxide bubble? Until and unless you jerk it. See. So in that case, solute is gas, solvent is liquid. So it looks liquid. So what should I write? That is actually you are supposed to know in class 12, but you should know in the beginning. So we'll write now the physical state or phase of a solution is the phase of a solvent. Understood now? Phases of solvent. Now see here. Please see. If a solution contains two components, means what? Solvent is always one. Solvent is there and only one type of solute. That type of solution is called binary solution. That is sugar in water, salt in water. If you put two solutes, so including solvent, it is three components. We call it ternary solution. Ternary, ternary or tertiary solution. If it contains four, we call it quaternary. Oh, forget now. So now, See, how can you classify solution? Solution can be classified in several ways. But we can classify solution on the basis of the amount of the solute present in the solution. Amount of the solute present in the solution. See, if you have made a sugar solution and to that you have added very less sugar. Suppose you made a cup of red tea and there you have put less sugar. So, and you have given it to someone. What the person will say?
It's not sweet.
It is not sweet. Or suppose if he is like me, you will say, ah, you are very conjush. No? Is it no? Will you say conjush? Kapna ma? In Khasi, what do you say? Conjush? No idea. Achha. But if a man, if he is a man from chemistry, you know what he will say? He will say
Unsaturated solution.
it is a dilute solution or unsaturated solution. So what is the meaning of a dilute solution or unsaturated solution? It is a solution in which some more solute can be added. Some more solute can be added. That is, amount of substance present in a solution we express grams per ml, or in other words we call it concentration. So dilute solution is that one whose concentration is less, and if you wish you can increase the concentration of it by adding some more solute. But suppose you go on adding solute into that and keep on stirring, a time will come there, you will not be able to dissolve further amount of solute. Okay? It's not possible. It is not good. No matter if you stir for half an hour also, if your hand started paining also, you can't. So what should you call that solution to be?
Saturated solution.
Super
Yes.
saturated solution.
No, not super. Saturated solution.
So saturated.
Saturated solution. So what should be the definition of a saturated solution?
If the substances are in excess.
It is a solution in which no more solute can be dissolved.
So they are in excess.
No. Please let me finish. It is a solution in which no more solute can be dissolved at that temperature. See, if you warm it, you'll find some more solute will go. But at that temperature, it is not going to dissolve anymore. So what I can say? What is a saturated solution? I can say saturated solution is that one whose concentration is constant at that temperature. Okay, so that is a saturated solution. Now, one of my friend already mentioned the word supersaturated. Supersaturated solution, how can you make it? You have to start with the saturated solution where you find some more substances have settled at the bottom because it has crossed their solubility. So if you warm it, then the solute will go and it will make a saturated solution at higher temperature. Now you cool down. When you cool it, that excess amount of the substance which it has dissolved, it will come out of it. It will come out. It will precipitate in the form of crystals. That is called supersaturated solution. So, supersaturated solution can be mentioned as it is a solution in which concentration decreases. Concentration decreases. See here. So if I go for dilute solution, see if I write here concentration, okay? Concentration in dilute solution, concentration increases. In saturated solution, concentration is constant. And in super saturated solution, concentration decreases. Concentration decreases. So you just think like that, that it is so your stomach is the solvent and solute is the food. If you take less food, you can take again after some time or that time only. If you have gone for stomach fill, no, you can't, you will refuse, I will not eat. But suppose under certain condition, your friend and everybody is requested, please have one more round of ice cream. Then you get tempted, you have taken. Then another person come, again you get tempted, again you have taken some more ice cream. A time will come, you have to vomit. Otherwise you will die. Concentration decreases. So we can classify the solution on the basis of their concentration. So I told you, concentration is being expressed as grams per ml. And at the very beginning, I told you in the fundamental unit, we have two things about the substance. One is the mass. And second is the amount of substance. First is weight of the substance, and second is amount of the substance. Amount of the substance is expressed in mole. So the concentration of solution can be expressed in two ways, grams per ml or moles per liter. So on that basis, I'm going to discuss something with you. Give me 1 minute time. So we can express the concentration of the solute or of a solution by two ways, either by expressing them in terms of their mass, and second, in terms of their moles. So when we express it in terms of their mass, dear, so that way, that type of expression is called percentage composition. Composition. Okay, so we'll go for percentage percentage composition. In percentage composition, you are not supposed to know the molecular mass of the substance. See, so many times you went to restaurant, huh? Did you ever ask them, the person who makes the tea, will say, sir, do you know the molecular mass of sugar? They do not know. But still they make the solution. Still they make the tea. So what is the unit of measurement? The unit of measurement is that in 1 cup of water, how much amount of spoon, how much amount of sugar should be added. So in our kitchen or in restaurant, we never take the weight of the substance. We use spoon as the unit of measurement. So you can go for 1 spoon, 2 spoon like that. Okay. But in chemistry laboratory, we are not supposed to make a solution by using spoon. So we go for percentage composition. Okay. So percentage composition can be of 3 types. A. We call it mass percentage. Mass percentage, or commonly we call it weight by weight percent. That is, we take the solute by weight, we take the solvent also by weight. You can take even water, you can take the weight. Okay, so that you call it weight by weight percent. All right, mass percentage. So what should I write now here? It is defined as the amount of solute in gram present in 100 gram of the solution. 100 gram is the solution. So if I have to express it mathematically, we call it mass percentage or weight by weight percent is mass of the solute divided by mass of the solution. Take care, solution into 100. This is the mass percentage or weight by weight percent. Okay, now see mass of the solution. So how to find out the mass of the solvent? See, mass of solution is equal to what? Mass of solute plus mass of solvent. In numerical, you should know how to find out mass of solvent. They will not give you. Mass of solvent is equal to mass of solution minus mass of solute. Right. Moment you finish, immediately say, you tell me.
Done, sir.
Done, sir.
Okay. So now we'll go for second one. Okay. B. We call it volume percentage, or we call it volume by volume. It is the volume of solvent in ml present in 100 ml of the solution. So what we can write mathematically, volume percentage, or V by V percent, is volume of solvent in ml, and volume of solution in ml into 100.
Done, sir.
So now, if it is say 10% ethanol solution, means what? In 100 ml of the solution, 10 ml is ethanol, 90 ml is water. Okay? So remember like this. Then third, we call it mass by volume percentage, or W by V percent. It is the mass of solute in gram present in 100 ml of the solution. So we can write now here mass by volume percentage, or W by V percent. So mass of the solute in gram divided by volume of the solution in ml into 100.
Done, sir.
Hold on. Please wait. Let me put little ink in my pen. So these are the solutions in which we did not know the molecular mass of the substance. Now, we'll come across another type of solution where molecular knowledge of molecular mass is essential. So, we have another way of expression. This is called molar solution or molarity. Its symbol is capital. So it is the number of moles of solute present in per liter of the solution. Okay. It is expressed as capital So now what? How can I write here? So I write here M is equal to mole of solute divided by volume of solution in liters. Okay. Let N is equal to number of moles. V is the volume in. So therefore I can write M is equal to N by V in liters. Okay. Now what is N? How to find out? Now it is the mass of the solute divided by molar mass of the solute. Okay. So let me write. Let W B. See, generally B we consider to be capital B considered to be solute and capital A we consider to be solvent. WB is mass of solute and capital MB is not the same M. MB is the molar mass of solute. Therefore, N is equal to WB by M. So I'll put this value here. I'll write therefore M is equal to WB by MB by V. You know this will come down in liters. Therefore, I can write M is equal to WB then MB V in liters. Okay, right up to this. Finished.
Yes, sir.
Yes, sir.
Again, you are giving quite na. Every time I have to tell you, huh? See now. So every time it is what if you want to make a molar solution, you have to take in liters. But suppose you require 100 ml, then your 900 ml is wasted. So we should be able to convert liter into milliliter. See how to convert liter into milliliter. If you divide it by 1000, then you will find it will be converted into milliliter. So I can write now MWB MB V by 1000 ml. So what will happen? It will come to the numerator. So therefore, what we can write? M is equal to WB 1000 MV and V in ml. So this is our final equation. Okay, we'll do a simple sum. Calculate the amount of sodium hydroxide present in 250 ml of 5 molar atomic mass of sodium is 23. They will not give anything more. So what will do? Solution, how will you do it? See here. We know M is equal to WB into 1000 divided by MB into B. Okay. So see here. What is the value of M? 5 molar. Okay. So you can write out if you wish to put this one 5 mole liter inverse. Then WB you are supposed to find. Is no calculate the amount of sodium present. Now MB. What is the molar mass of sodium hydroxide? What is the formula of sodium hydroxide? NaOH. So it has only one sodium. So 23. What is the atomic mass of oxygen?
16.
16. What is the atomic mass of hydrogen?
1.
1. Total is how much? 40 gram mole inverse. Now what is V? See here. 250 ml. Okay. So from there, find out W. You know how to do it by cross multiplication. Do.
So 50 grams of sodium hydroxide present.
How much?
50 grams of sodium hydroxide present.
Okay, then we write like this. That WB is equal to what? M into MB V by 1000. So what is M? 5. MB 40. V 250 ml divided by 1000. So this and this will be 4. This is 10. So it is 50. Now I'll show you two more relationship which is needed for your entrance. So we'll write down here relation between molarity means what? M and mass by volume percent. So it is X%. Solution. See. So I'll write it like this. M. Okay, this is the M. Then what is there? WB 1000, then MB and see what is the WB? Is X gram because mass by volume percent, na X gram. What will write here? WB is equal to X gram. What is the volume? Moment is percent means 100 ml. So volume is what? 100 ml. We will put this here. Therefore, M is equal to X into 1000 divided by MB into 100. Okay. So this and this get cancelled. Therefore, M is equal to 10x by M. See, this is a shortcut. This is required for your entrance exam or any numerical given in your school.
Done, sir.
Okay. So let us do a numerical. Calculate the molarity of 15% sodium hydroxide mass by volume solution. This is the formula. Find it. You have to calculate molar mass of sodium hydroxide. Just now you have done. You know how to do it. So, what is the result?
The 3.75.
Is equal to what? 15. MB is equal to what? 40. Just now you have calculated. So M is equal to 10 into 15 divided by 40. So this and this get cancelled. So it is 15 by 4. So it comes to how much? 3.75.
75.
This. What will be the expression? Moles per liter. See. So if you know the shortcut, you can immediately do it. Now, I'll write one more. Whatever we learn, we'll learn it complete. No shortcut business. See, so this is our relation, huh? M is equal to WB 1000 MB into V. Here no volume is there. Both the solute and solvent taken in gram, so volume is not there in 100 gram of the solution. So we have to convert this gram into solution. Now see, let D be the density of the solution. Okay, now see, density is what? Mass by volume. Yes. Therefore, volume V is equal to what? Mass by density. What is the mass, total mass of the solution? 100 gram. In mass percentage, solution. Mass of the solution is 100 gram, dear. So therefore, what should I write now here? Therefore, V is equal to 100 divided by D. Right up to this. Then I will again do it. See, as per this yesterday's announcement, I think your class will start from 1st September. Let's see. I believe that all the school will be over by 3. Only BSF school runs up to 3:05 or 3:10. We'll try to adjust time. Yeah, don't worry. We are facing some problem with the Saint Margaret School. Finished.
Yes,
Yes, sir.
Yes, sir.
You could understand now here. Mass percentage means here solution is taken the weight. We did not know the volume. So because of that, we try to find the volume. Okay. Now, so what I do now? I put these values here. So therefore, what? WB is equal to X gram. Okay. And V is equal to what? 100 by D. So I'll put it here now. So it will be M will be equal to X into 1000 divided by MB 100 by D. So D will come to the top. So it will be what? X into 1000 into D divided by MB into 100. Therefore, M is equal to 10 FD by 100. So, I think I think the training of the module is the major part of the background. Okay. So we'll do one numerical, very simple numerical. If you do not know this formula now, then it is difficult for you. Calculate the molarity of 15% H2SO4 solution, H2SO4 mass percentage solution. Density is equal to 1.02 gram ml inverse. Do. See, I'll not write. H2SO4, do you know? Atomic mass of sulfur is 32 gram mole inverse. Do. Immediately do, because I have to start class 12.
So 1.56.
Yes, good. And unit will be mole liter inverse. Mole liter inverse. Okay. Anyway, these two equations are not given in your book, but you should know because for your entrance exam. Okay. So tomorrow we'll do. I'll try to see if I can finish it in this week, because this basic concept is most important. If you do not know the basic there, you will not be able to do anything. So bye for today. I'm sorry that today I could start because I have class up to 3 o'clock. So it is continuing up to 3:10. So I got little delayed. And I should give some time to dry up. My board should be dried up now. Okay. So bye for today.
Thank you,
Thank you,
sir.
sir. Bye, sir.
Thank you, sir. Bye. Bye, sir.
Thank you, sir.
Thanks, sir. If you have any problems,
sir.
if you have any problem, you can then and there ask me. If not, you can in the group also you can post. And suppose if you have any doubt, and if your friend knows it, immediately reply this thing in your group. Then you will find to teach your friend, your doubt will also be clear. Let us go for a group discussion. This group you not only use only for making the post when you will have the class, and I'll inquire about the fees and all these things. Not only that, if you have any doubt, you can request your friend. If you have a numerical, request your friend that I am not able to do it. Maybe your friend will be able to do it. So if your friend does it, okay, so for him it is a practice. Next day you do it for your friends. You'll see, you'll enjoy by exchanging your note. And if you have any doubt, if I find that both all of you are not able to do it, then I shall do it for you. I shall do it and take photograph and send it in this group. Okay. Utilize your group. You see how much you'll benefit. Don't every time don't depend on you on the teacher. In my personal life, I have learned more chemistry from my friends than from my teachers. If all of you fail, then I'll wait for one day. Then next day I'll do it. Okay. Make it is a this group is make it. It is a group discussion group. Okay. Bye.
Bye, sir.